Here we have these functions and we want to differentiate. So we'll start with this function z. Here notice this is a fraction. This is a function over a fraction, so we can use the quotient rule to take the derivative, but here I'm gonna use the product rule to take the derivative. I just want to show you how to not use the quotient rule and instead use the product rule. So what I'm gonna do, I'm gonna write z so that I can use the product rule. So I bring the bottom up and the power is -1, and then I assign the first one to f and the second one to g. So again, f will be t squared plus 3t plus 1, and g function gonna be t plus 1 all to -1. Now I'm gonna take the derivative of each. This is using the power rule, and then for g what I'm gonna use is first the power rule, and then I'm gonna apply the chain rule to take the derivative of the inside, which is just 1. And this term can be written as -1 over t plus 1 all squared. So z prime gonna be f prime by g plus f by g prime. So the first term is f prime by g, and then the second here is f and multiply it by g prime. I'm just plugging the values of these function into the z prime, and now I'm gonna take t plus 1, the -1, and put that into the denominator. And then notice that we have negative sign, so we'll bring that in front, and we'll have t plus 1 all squared. Now I want to find a common denominator, so what I'm gonna do is I'm gonna multiply the first fraction by t plus 1. So now what we have, you notice here we have a common denominator. What does that mean is that we can now subtract the numerators. Notice here the negative sign is in the front of the second term. This negative sign is multiplied by the whole terms. I'm going to show you a couple of seconds. Oh, what's the fraction? So this is what is the result. This I'm just subtracting. I did not do anything, and then we can leave it as here. We can simplify more, but I'm gonna just leave it as here. Here we have y as a square root of t over t squared plus 1. Since this is a fraction, we can use the quotient rule. So I'm gonna assign f to the top and the second and the bottom to g. We can also use the product rule, but here I choose to do the quotient rule. So f again gonna be assigned the top and g gonna assign the bottom, and then I'm gonna find their derivatives. Now after finding these functions, I'm ready to plug that into the quotient rule. So I'm gonna, first term I'm gonna multiply f prime by g, and the second term I'm gonna multiply f by g prime. I remember all of that is over g squared. Now what I'm gonna do, I'm gonna transform the t to negative half to 1 over the square root of t. And then I'm gonna leave everything the same. Here I brought the 2 in front of the square root in the second term, and that's the derivative of y. Now we have this function. First, what's the derivative of the first term, k to the x? Remember, this is just using the power rule. K here is just a constant. And then we have a derivative. This is an exponent. So it's going to be natural log of k multiplied by k to the x, not a to the x. I'm going to fix that very soon. This came from the derivative of a to the x as natural log of a multiplied by a to the x. So now we are ready to take the derivative of g. This is the derivative of the first term and the derivative of second term as natural log of k multiplied by k to the x, and that is the resulting derivative. Now we have this function here. We can just take the derivative here using the product rule, but it is easier to simplify first. So I'm gonna multiply the square root of theta in front, what's in the parentheses. So here in the first term, what we have as square root of theta multiplied by square root of theta is the same as theta to half multiplied by theta to half, and now we can add the powers, and that's gonna be just theta. So the first term gonna be theta, and then square root of theta over square root of theta is just 1. This is y. Now it's much easier to take the derivative, which is just 1. Now we have this function f of y, and then we have natural log of 2y cubed. Here what we're gonna use is the chain rule. So remember that the derivative of natural log is just 1 over x. So first will be outside function, so it's gonna be natural log over what's inside in front. And then I'm gonna take the derivative of what's the inside, which is natural log again, but gonna be over 2y cubed, and then the derivative of the inside again, which is gonna be 2, which is a constant, multiplied by 3y squared. Then I'm gonna simplify here. Now I'm gonna bring the 3 in the front, then I'm gonna bring y to the front, and then natural log of 2y cubed, and that is the resulting derivative. Here we have this function here. We can use the quotient rule in here, but it's a lot easier if we rewrite that function into 1 plus e to the negative theta to the negative 1. Now what we have to do is just use the chain rule. So first we will use the derivative of the outside function with just using the power rule, and then the derivative of the inside function, derivative of 1 is just 0, and derivative of e to negative theta is e to negative theta multiplied by the derivative of the inside, which is minus 1. Now we are just simplifying. So what we notice here, there are 2 negative signs, so we multiply these, we will have a positive. So I'm going to write the term, but it's going to be positive. Now what we have to do is we have negative 2, and then we have negative theta. So both of these terms will go to the bottom and can be written as a fraction. Now we have this function g of alpha, and remember, since we are given tan and sine, the derivative of tan of x is 1 over cosine square of x, and the derivative of sine of x is cosine of x. So we have to use the chain rule in here. First we'll take the derivative of e, and then tan, and then sine. So g prime gonna be the derivative of the outside, which is just the same, gonna be e to the tan of sine alpha. And the derivative of the inside is gonna be the exponent. The derivative of the outside gonna be tan, so 1 over cosine square over what's in the parentheses. And then the derivative of the inside, which is sine, so the derivative of sine is cosine, and then the derivative of alpha, which is 1. Now I'm just bring that into one fraction. So I brought the cosine alpha in the front, and then all over cosine squared sine of alpha. Here we have this function f of r. This is all to the power e. This is a reminder so we don't confuse ourselves. E is just a number. So what we're gonna do to differentiate this function is first use the chain rule. So the derivative of the outside, just using the power rule, and the inside gonna be the same. And then since this is the power rule, it's gonna be e minus 1. This is just again using the power rule. And the derivative of the inside, derivative of tan of 2, this is just a constant, therefore it's just 0. Then the derivative of tan of r gonna be cosine squared of r. Gonna simplify in here. Here we have this function y. What we're gonna use, since this is 2 multiplied function, we're gonna use the product rule. And also we're gonna use the chain rule when we are differentiating sine square of 3x. So first we're gonna rewrite that function. So sine square of 3x is the same as sine 3x all squared. So I'm gonna assign f to e to the 2x and g to sine 3x all squared. Then I'm going to take the derivative of each. Derivative of f prime going to be e2x, and then using the chain rule, multiply by 2, and g prime. So I'm going to use the chain rule also in here. First we will use the power rule, so 2 of sine 3x, and then the power going to be 1 since it's subtracted by 1. And then the derivative of the inside is cosine 3x, and then again the derivative of the inside is 3. So 2 multiplied by 3 is 6, and then sine 3x cosine 3x. Now we are ready to apply the product rule. So first term I'm going to multiply f prime by g, and second term I'm going to multiply f by g prime. Here what we notice that we have common terms in both first and second term. So we have sine 3x and then e to the 2x. We can factor these two. So we will end up with what's inside 2 of sine of a 3x, and then plus 6 cosine of 3x. That's our derivative. Now we have this function. What we're gonna use here, we're gonna use the product rule since this is 2 multiplied function. So I'm gonna assign the first function to f and the second function to g. So f gonna be 2 to the sine of x, and then g gonna be cosine of x. Now we want to differentiate this e to the sine of x. We're gonna use the chain rule here, but remember the derivative of a to the x is natural log of a multiplied by a to the x. The derivative gonna be a natural log of 2 multiplied by 2 to the sine of x, and then derivative of the inside, so derivative of sine of x is cosine of x. Now derivative of g is negative sine of x. So now we are ready to use the product rule. I'm gonna just plug these functions into the definition of the product rule. So I'm gonna first multiply f prime by g, and then multiply f by g prime. Gonna be natural log of 2 e to the sine of x, and then cosine of x multiplied by g, which is cosine of x, then plus the f function, which is 2 to the sine of x, and then multiply by g prime, which is negative sine of x. Now what we have 2 cosines of x, so this term gonna be cosine squared of x, and then I'm gonna bring the negative in front. I'm gonna be 2 to the sine of x multiplied by sine of x, and that should be our y prime. Here we have this function r of t. Here we're gonna use the chain rule since this is a composite function. However, I like to rewrite that. So what I'm gonna do, we have t over k. I'm gonna write that as 1 over k multiplied by t. So now we are ready to take the derivative. Natural log derivative gonna be 1 over what's inside in the parentheses, and then I'm gonna use the chain rule to take the derivative of the inside, which is cosine of 1 over kt. Then again the chain rule to take the derivative of the inside, which is just 1 over k. Now I'm just bringing these together, so I'm gonna be 1 over k, and then cosine t over k, and then over sine of t over k.